Hello, everybody. I'm Jonathan Carnes. I'm Senior Product Manager for File Services on FlashArray.
And I'm Manish Agarwal, Senior Director of Product Management for FlashArray File Services. Today, we are going to be talking about FlashArray File Services. We'll give you an overview of how we built FlashArray File Services, how it's different from the competition. So John, to get us started, why don't you first introduce what is FlashArray?
Sure. FlashArray is Pure Storage's data storage platform that supports both block and file. So it's built out of all NVMe flash, which has data efficiency built into the system through software. Things like global storage pool, global dedupe, non-disruptive software and hardware have all been built into this platform. Additionally, it takes part into the Evergreen program here at Pure, which allows you to seamlessly upgrade between different models of array without having to migrate data. Some of the block protocols they built on here were Fiber Channel, iSCSI, NVMe over Fabric, NVMe over TCP, and vVols, to list a few. And these are all built on top of the data efficiency layers and the all NVMe flash. Manish, do you want to tell us a little bit about how we use that platform with file services?
Sure. So before I talk about FlashArray File Services and how that's built differently, let me talk about the legacy systems. These are old architectures. They are built 20, 30 years back. There was no flash at that time. So these were primarily built for hard drives. And first thing they did was basically retrofit it for flash. And in the process, they introduced a bunch of trade-offs and compromises. Then the next thing, when these architectures were built, they were built either for the block world or for the files world. So if they were built for files, you would have an implementation of SMB and NFS. They would layer on a implementation for blocks. So you would, for example, build in Fiber Channel or iSCSI on top of it. And this introduced an additional set of compromises, which basically leads to a house of cards. Now let me come over to the Pure side. So this is our implementation of file services. This is a new, completely new stack that we built from the ground up. It is a first-class citizen. The file stack and the block stack basically are built directly on the storage layers. They are not layered upon one over the other. And it shares some of the benefits of data efficiency and all NVMe flash. And it gets all the file stack gets all the properties such as a global storage pool, which allows it to build a infinitely large file system. There's no limitation in terms of how large they can be. They can consume the entire array. There's global dedupe, non-disruptive hardware and software, and obviously the Evergreen program as well. The way we built it is it's built on a layer of objects. Built on the objects is a file system. And on the file system runs the file protocols, SMB and NFS. Now, by doing this, because they are both directly built on the storage tier, they're not sharing any abstractions. There's no limitations. You're always, when you're managing files, you're managing natural constructs of files. When you're managing block, you're managing directly blocks, not blocks on file systems. So to take us further, a little bit deeper into this, John, why don't you walk us through the management model that we built for files?
Yeah. So taking advantage of what Manish just said, like being able to have a large file system, not based on your block limitations, we decided to take a management model that didn't focus on the file system anymore. You don't need to do much there. If it's unlimited size, we can control it other ways. So we decided to go with a managed directory-based configuration and management style. So we combine that with the ability to use what we call policies. And policies are just reusable sets of rules that you can apply to managed directories. So let me give an example of this to kind of help define this. So if I was on file services and I wanted to create my file system, and obviously I can create more than one, but we'll just create one for this. The first thing I will see is I get my first managed directory. And we call that managed directory root. So obviously I can apply configurations to this managed directory and I can control the file system layer here. But I can obviously I'll probably want to create more directories below. So we'll create a couple directories here. So we'll just create 2 directories down. You can create multiple managed directories below a file system. You can create up to 7 layers below, and they can go different directions, or horizontally or vertically. But the idea here is that these managed directories will allow me to do a couple different things. I'll be able to monitor them by viewing their space and performance, statistics. I'll also be able to apply policies to them. So let's look at what policies can do for us. So we have 3 types of policies. So we'll get 3 boxes. We have export policies. We have snapshot policies. And we have quota policies. So with an export policy, what that allows us to do is to say we want to export out via one of the protocols that we support, SMB or NFS. So by setting up a set of rules here, such as like who I want to have access, how I want to handle root or anonymous access, whether the rule is about SMB or NFS, I can just simply attach this to 1 or more directories and allow me to export those all out via either protocol or both protocols if needed. We do support cross-protocol access. Same thing goes for snapshots. With snapshot policies, I can go and configure schedules for snapshots, retention times, and then I can actually take that schedule and apply it to, again, anywhere I need to. And what this allows me to do is say, even if I need to, I can take file system snapshots, but maybe I don't need to. Maybe I only need to take something lower down the file system to save myself from consuming snapshot bloat in my storage. So this will allow you to do that. And these are many-to-many configurations. So you can have many export policies to a single directory, or you can have multiple directories connected to a single export policy, and vice versa for all the rest. Same thing for quotas. If I want to apply that to any level I want, I can. What this allows me to do is set hard and soft quotas to any of those directories. So all these are very useful in certain situations. For example, quotas is very useful when you're doing home directories. So if I have a home directory here that I want to apply a subquota to, I can do that. Maybe if in the world of VMs, maybe I want to take snapshots of just my VMs that are belonging to an NFS data store, I can do that. So this allows you to have granular control over top of your data, be able to efficiently use all the space on the array and not consume more than you need to, but also be able to do whatever you want wherever you need to.
So that was an overview of FlashArray File Services and the granular data management model that we built on top of it that you can use to manage home directories, user shares, shared directories, or scale it down to the granularity of individual VMs. And comparing that to a legacy architecture, a house of cards, what we've built is a pure unified storage system. Thank you for your attention, and reach out to us if you want to know more.